March 1980, an ordinary mountain in Washington state suddenly started acting weird. After 123 years of silence, thousands of earthquakes begin rumbling beneath it. Authorities declare a red zone around the area. Step inside without a permit, get fined, or go to jail. Up to 10,000 tremors are recorded, and the mountain's northern slope keeps swelling larger and larger. Everyone's waiting for the moment when lava finally emerges. And at 8:32, this happens. A lateral blast moving at nearly the speed of sound, with the force of an atomic bomb. The mountain is literally blown apart. The aftermath is something no one had seen before, the largest landslide in recorded history. The strangest part? Despite all that power, there's no lava. And that detail is the most important one here. Because this volcano just showed us what we all need to start preparing for right now. An unobtrusive reminder to do that thing under the video. And this eruption on May 18, 1980 forever changed the face of the region. The perfectly symmetrical, snow-white cone that once appeared on postcards simply vanished. In its place stood a torn, jagged peak sticking out in every direction. But far more was lost that day than just a flawless silhouette. Trees were snapped, countless wild animals died, the Toutle River was choked with mud and debris, Spirit Lake spilled out of its banks, hundreds of homes were destroyed, and 57 people lost their lives. Even the sun disappeared. Only a bleak grayness remained. Overall, Mount St. Helens is considered part of the Cascade Range, which stretches from northern California all the way to southern British Columbia. These mountains hold an honored place among the volcanic giants of the Pacific Ring of Fire. You've almost certainly heard of that ring of volcanoes circling the Pacific Ocean. So precisely because of the Ring of Fire, the eruption wasn't anything sudden or even unexpected. Mount St. Helens had pulled off something like this more than once. Its previous eruption happened back in 1853. But what happened in 1980 included something truly unusual. The mountain had started showing signs of life back in spring, and it instantly drew the attention of the entire country. The U.S. Forest Service, the Geological Survey, and local authorities scrambled to assemble a response team, while TV crews were already crowding the area, setting up tripods and chasing any hint of smoke. Behind the barricade stood regular people, waiting for a show. They wanted to see lava, smoke, anything at all. Some even made t-shirts with slogans like, "Yeah, sure," as if they were teasing the mountain and daring it at the same time. Strange, I know, but it was the 80s. On March 27th, the volcano finally erupted. A plume of smoke and ash shot nearly 6,900 feet into the air. But that was just the beginning. For the next 2 months, the mountain shook, wheezed, quivered, living its own jittery life. In March, tiny eruptions were happening almost every hour, and by April 22nd, they had gradually slowed to about one a day. That's when the first wave of activity quieted down. The pause didn't last long. On May 7th, new minor eruptions began and continued until May 17th. And throughout this period, more than 10,000 earthquakes occurred. 10,000! Meanwhile, the northern slope swelled, pushing outward by about 459 feet and forming a huge, visibly bulging dome. And then it collapsed. And now the important part. All of this triggered one single action. Which one? First, the coffee intro. On May 18th, it all began with a massive jolt. The earthquake yanked the mountain so sharply and so violently that the entire northern flank tore loose and slid down, turning into the largest landslide in recorded history. A gigantic avalanche of rock, mud, and trees buried 14 miles of the North Fork Toutle River Valley under an average of about 150 feet of debris, and in some places up to 590 feet. Like a multi-story building made of rock and dirt that simply collapsed on top of everything. And then came what you could call the champagne effect. As long as the mountain kept all that pressure locked inside, things looked relatively calm. But the moment the slope gave way, it was like the cork popped. Scorching rocks, scorching gas, steam, and a massive amount of ash shot upward and blasted northward. The eruption scattered volcanic debris across roughly 232 square miles, and along with it, the wind carried off about 335 million cubic feet of timber. The blast wave was so powerful that it smashed into the upper layers of the atmosphere, bounced back and slammed downward again, sweeping across Greater Vancouver and the southern part of Vancouver Island. A year later, journalists from CBC News said that if the explosion had been just a little stronger, it would have blown out every window in Vancouver and Victoria. This eruption became the deadliest in U.S. history. Entire landscapes vanished within minutes, and ash swallowed roads, forests, cities. Witnesses later recalled that the ash destroyed absolutely everything around it. The leather on boots, buckles, belts, cameras, glasses. Scientists declared that the mountain had changed beyond recognition. People who lived through that day said that everything that had once been green and alive had turned gray and dead, as if someone had simply switched the colors off. The ash lay on the slopes in such a dense, heavy layer that cars could easily be buried underneath it. In total, about 193 square miles of land were covered in ash and pumice, a vast destruction zone stretching up to 17 miles from the volcano's summit. According to estimates, the damage reached about $1.1 billion in 1980 dollars, an enormous sum for that time. And yet, unexpectedly for an eruption of this scale, there was no lava, no familiar streams of glowing magma, not a drop. Instead, there was something entirely different. Volcanic mudflows were cascading down the entire southern side of the mountain. Scientifically, they're called Lahars, but in simple terms, they're gigantic rivers of mud, debris, and water that race down a volcano at terrifying speed. It all began literally within the first minutes after the explosion. Part of the scorching clouds spilled over the edge of the new crater and rushed down the western, southern, and eastern slopes. These violent torrents of hot rocks and gas were melting the snow and ice that covered the volcano. The ice melted, the water mixed with rocks and mud, and all of it surged through the river valleys, ripping out trees by the roots and sweeping away roads and bridges. The largest and most destructive lahar moved into the North Fork Toutle River Valley. At first, the water beneath it came from ordinary groundwater and from meltwater released by massive blocks of glacial ice. But once this whole flow passed out of the landslide zone, it began eroding everything in its path, including the landslide deposit itself and the riverbed. As the lahar traveled downslope, it grew, becoming wider and heavier. It tore apart bridges, homes, and all infrastructure that happened to lie in its way until, eventually, it reached the Cowlitz River. By midnight, this flow had reached its peak strength roughly 50 miles downstream from the volcano, far from the place where it had all begun just a few hours earlier. Now let's take a closer look at what was happening inside the mountain. On May 18, 1980, an earthquake with a magnitude of a little over 5 happened. The jolt tore away a massive portion of the northern slope, and the pressure at the summit dropped sharply. This destroyed the so-called lava dome. In simpler terms, a dense plug of solidified rock that had been holding all the steam and gas inside. Once this plug blew off, the hot water inside the volcano instantly turned into steam. That steam began expanding with such force that it triggered a powerful lateral blast, shooting straight out through the gap created by the landslide. And that was only the first stage. The top of the volcano was gone, and the pressure on the magma deep below suddenly plunged. This wave of pressure loss traveled down through the volcano's internal conduit toward the magma reservoir. The magma began rising, releasing gas and foaming vigorously. Basically, it's like opening a shaken soda bottle. In the end, the whole system blew wide open, and 9 hours of what's known as a Plinian eruption began. A Plinian eruption is when a volcano ejects a massive column of ash, rocks, and gas high into the atmosphere, rising many miles into the sky before spreading outward like a giant umbrella. All of that eventually falls back to Earth as a thick ash blanket over enormous areas. The name comes from Pliny the Elder, who witnessed the eruption of Vesuvius in 79 AD. Interestingly, the 1980 Mount St. Helens eruption wasn't the most powerful or the longest in the volcano's history, but it became the first major eruption in the continental United States that scientists were able to study with modern instruments and methods. Why didn't we see the familiar rivers of lava? Deep beneath the ground, the temperature's so high that rocks start to melt and turn into a thick, superheated mass. That's what we call magma. It's lighter than the surrounding solid rock, so it rises upward and collects in special underground pockets inside the volcano. These are called magma chambers. Once magma breaks through to the outside via vents or cracks, it becomes lava. But not all volcanoes erupt in the same way. Sometimes magma is thin and fluid, it contains a lot of molten material, and gases can escape easily. In that case, the magma simply flows outward. This is exactly what happens with Hawaiian volcanoes. Their lava flows fairly calmly without sudden explosions. It looks terrifying. but most of the time people can safely move out of its way. But there's another scenario when the magma is thick and sticky, trapping gases inside. Pressure builds up like in a pot with a tightly closed lid until everything finally blows apart. That's exactly what happened at Mount St. Helens. Instead of quietly spilling out, the magma rose, then fragmented into a massive amount of debris. All these rocks, ash, and pumice are called by one word, tephra. This term refers to any fragments of rock a volcano hurls into the air during an explosive eruption. But explosive eruptions don't just scatter pieces of rock, they can release enormous clouds of scorching hot tephra and gas that race down the volcano's slopes at tremendous speed and destroy almost everything in their path. And you know what? The volcano still reminds everyone that it's there. On September 16, 2025, residents of the Pacific Northwest woke up to a strange scene, a hazy plume hanging over Mount St. Helens. Many immediately thought, well, that's it, it's happening again. But no new eruption followed. The wind had simply decided to trigger a flashback. Strong gusts lifted old ash back into the air, the same ash that's been sitting around the mountain since 1980. There's so much of it in the soil and along the slopes that from time to time it rises into the atmosphere again and scares the locals. Yes, even 45 years later. After the eruption, this entire area in the southwest of Washington state looked like a lifeless desert. But beneath that harsh surface, fertile soil was still there. You just had to reach it. And that's when scientists decided to test a curious idea. What if they let the local engineers get to work? The gophers. They're called that because they reshaped their habitat dramatically, practically rebuilding everything with their paws. The gophers, to put it mildly, were not thrilled. They were relocated from their familiar home, the volcano's southern slope, to the northern side, to a place called the Pumice Plain. After the eruption, it was covered in loose pumice with almost no carbon, nitrogen, or other nutrients. The gophers were brought there for just a day and then taken back. But those 24 hours turned out to be enough for the landscape to start changing. When the scientists returned to the fenced-off plots 6 years later, they were stunned. In the spot where the gophers had stayed, about 40,000 plants had grown. Meanwhile, the surrounding areas remained as barren and desolate as right after the disaster. And the farther they looked, the bigger the contrast became. So what exactly did the gophers do? First, they dug. A lot. Through their burrows, they brought old, fertile soil up to the surface from beneath the layer of ash and pumice. Second, they left behind a surprisingly valuable kit, everything from their own droppings to spores and microscopic fungi. You could say the gophers carried a piece of their previous ecosystem with them. Seeds, spores, bits of soil, all of it ended up in their claws, in their fur, and even in their digestive systems. And the most important role was played by beneficial fungi, which help plants grow even in places where it seems nothing should ever be able to survive. Now let's head over to New Zealand, because something erupted there as well, and it's definitely worth a look. Almost 40 cruise ship passengers wearing shorts and t-shirts stepped off in the port of Tauranga, ready for a day of fun and adventure. Some went on land tours, while 4 tourists chose the most spectacular option. They hopped on a helicopter and flew out to a remote, uninhabited island. Just a normal sightseeing day, late 2019. No one could have imagined how it would end. December 9th, 2:11 p.m., the volcano erupted. At that moment, 42 tourists, 4 guides, and a helicopter pilot were on the island. The island is called White Island, or Wakari in Maori. It's New Zealand's most active volcano. It's been restless since 2011. Scientists had been seeing signs of increasing activity for weeks, but the eruption was still sudden and deadly. 22 people died, some right there on Wakari, others later in hospitals. That's nearly half of everyone who was on the island. Another 25 people were seriously injured, many with severe burns. Most of the victims were tourists, 17 from Australia, 3 from the United States, and others from Germany, China, New Zealand, and several more countries. In just 2 fateful minutes, the island became the site of one of the worst tourist disasters in the country's history. After that, all tours to Wakari were shut down. Wakari sits in the Bay of Plenty, about 30 miles off the northeast coast of New Zealand's North Island. When you look at it on a map, it seems small, but in reality, roughly 70% of it is hidden underwater. It's an active volcanic island with hot springs, geysers, and vents that release scorching gases. These are called fumaroles. It's part of the massive Ring of Fire, the zone around the Pacific where tectonic plates collide and where hundreds of volcanoes are clustered. So activity here is the rule, not the exception. And White Island has quite a record. It erupted almost continuously from 1975 to 2000, and then again in 2012 and 2016. Those were steam, mud, gas, and ash eruptions. New craters appeared, but no one was harmed. Since the volcano was active and open to tourists, scientists monitored it very closely. But the December 2019 eruption turned out to be something else entirely. According to experts, water somehow made its way to the molten magma inside the volcano. It flashed into steam instantly, and the pressure began to build like in a steam boiler. The volcano's surface was covered by a layer of mud and debris, and for a long time the steam couldn't escape. At some point, holding it back simply became impossible, and the explosion happened. Rocks and toxic gases shot into the air, and a column of steam and ash rose about 12,000 feet high. During the official investigation, an employee who happened to be on the island that day testified. He said that at first everything looked calm and seemingly safe. The group of tourists was walking toward the streams in the center of the island. There was no noise, no shaking, just a sudden explosion. Another witness recalled lifting his head and seeing a gigantic column of smoke, black and white in stark contrast, appearing out of nowhere. People didn't even have time to hear a warning rumble. At first, many even thought it looks beautiful. Blue sky, a dramatic pillar of steam and ash, almost like a scene from a movie. But those thoughts were instantly replaced by others. We need to get out. One survivor remembered simply shouting for everyone to run. The tourists tried to move away from the danger, but soon realized it was advancing too fast. So they dashed toward large boulders, hoping to shelter behind them. And that's when I saw the pyroclastic flow coming down, one witness said. I remember putting on and holding my gas mask and my sunglasses to my face, basically shielding my face, and then the pyroclastic flow came over us. According to geological specialists, pyroclastic flows are the deadliest part of explosive eruptions. They're clouds of burning hot rocks, gas, and ash racing down the slope at high speed. They form when part of the volcanic plume collapses back to the ground and turns into a rolling mixture that resembles an avalanche of fiery dust. Volcanologist Shane Cronin explained during the hearings the temperature of particles inside such a cloud can exceed 752 degrees Fahrenheit and average around 392 degrees. In other words, being anywhere near such a flow is extremely dangerous. When the flow passed, an unusual heavy silence settled over the island. Survivors still hoped that help would arrive immediately, but unfortunately the evacuation took time. After the blast, the survivors tried to gather together and make their way toward the jetty, hoping for help from the sea. They managed to attract the attention of the tourist vessel Phoenix, which was nearby, but even then things weren't easy. The ship first had to be cleared of hot ash and debris so people could board safely. Other members of the group who ended up near the water and tried to hide in the ocean were also spotted and brought aboard. One survivor recalled that every surface felt scorching and dangerous, so he practically rolled into the boat trying not to touch anything. The marine operations manager working that day testified that the pyroclastic flow had covered almost the entire island, and the shoreline only became visible again a few minutes later. He noted that at first, no one on the shore could be seen at all, and the air was so thick with ash that it felt like dense fog. And again, no lava. No rivers of molten rock, no glowing streams that people usually associate with volcanoes. A single blast of steam, gas, and rock was enough to cause immense destruction and end in tragedy. Tourist Annie Liu, who testified via video link from Australia, said they had not been warned in advance that the volcano was at level 2 activity. Under New Zealand's 6-point scale, that means moderate to heightened volcanic unrest and a real chance of an eruption. Before the tour, they were given helmets and gas masks, but no one clearly explained why they might be needed, and no one said they should wear or bring anything beyond closed shoes and comfortable clothing. The impression that we were given basically was that it was just a casual day out, she said. Liu suffered burns to 38% of her body, which required several skin grafts and left her with scars. Think of if you open an oven and the heat just rushes at you. it's kind of like that, but 1,000 times worse. To be honest, I really don't want to imagine that, especially knowing the heat waves reached 212 degrees Fahrenheit and above. Whakaari is one of those New Zealand volcanoes that can erupt almost at any moment. Here, magma sits fairly close to the surface, and the heat and gases rising from below constantly interact with underground and surface water. The result is a powerful heated system, like a giant natural kettle. Water seeps into the pores of the surrounding rocks and stays there in an overheated state. Everything depends on a very delicate balance, and any external event, an earthquake, a fresh pulse of gas, or even a change in the water level in the nearby lake can disturb this equilibrium and sharply reduce the pressure on the trapped superheated water. When that happens, the water flashes into steam and an eruption begins, one powered entirely by steam. This type of blast is known as a hydrothermal or phreatic eruption. Such explosions can occur suddenly and with almost no warning. The most striking part is the speed. When water turns into steam, it expands at supersonic velocity and can increase in volume by roughly 1,700 times. That's more than enough force to tear apart solid rock, create a new crater, and hurl rocks and ash hundreds of feet in all directions. There are documented cases in New Zealand where such blasts have thrown material more than 1.8 miles from the vent. So yes, the volcano wasn't showing lava because the main energy source wasn't magma but steam, and tracking these eruptions is much harder. Steam is far less visible and doesn't produce the clear warning signs that rising magma does. Just in case, here's this schematic drawing of the volcano. As you can see, magma is present, but it lies deep beneath the ground and the water, well below sea level, and never actually reaches the surface. And now let's move to Japan. In September 2014, Mount Ontake suddenly erupted while several hundred tourists were nearby. No one expected any danger. Just minutes earlier, people were enjoying the views, hiking along the trails, and then everything changed in an instant. At 11:52 a.m. local time, columns of ash and hot gases rose above the summit. No warning tremors, no noticeable signs, just a sudden explosion. Ash covered the slopes and the nearby lodges and structures. Most people that day managed to escape, but many suffered serious injuries. 63 people were killed and around 40 more were wounded. It became the deadliest volcanic eruption in Japan since World War II. This photo captures the scale of the eruption perfectly. Just compare the column of steam and ash to the military helicopter, which looks tiny beside it. And here's what the mountain huts located near the crater looked like right after the eruption. All of them were covered with a thick layer of volcanic ash. Mount Ontake is actually a high mountain about 10,000 feet above sea level on the border between Nagano and Gifu prefectures. And during the eruption, hundreds of climbers were trapped near the summit, trying to find shelter in small mountain huts. About 230 people were able to make their way down on their own. The remaining roughly 40 had to be evacuated by rescuers. Prime Minister Shinzo Abe sent in the military to assist on site, and people within a radius of 2.5 miles were warned about the risk of new eruptions. Eyewitnesses recalled that everything happened like a sudden clap of thunder. The owner of a small hotel near the summit said, "I heard boom, boom." Then everything went dark. A thick layer of ash quickly settled on the ground, about 6 inches. One of the climbers said that he immediately tried to run, but was quickly covered in ash. In video shot by tourists on their phones, you can see gray clouds swallowing the sky, forcing people to stop their ascent. A worker at a mountain hut recalled, "All of a sudden, ash piled up so quickly that we couldn't even open the door. We were really packed in here, maybe 150 people. There were some children crying, but most people were calm. We waited there in hard hats until they told us it was safe to come down." And this photograph was taken by 59-year-old tourist Izumi Noguchi, who later became a victim of the Ontake eruption. It shows a hiker standing on the shrine summit watching plumes of gas and ash rise after the eruption began. Mount Ontake, or Ontake-san, is a stratovolcano. This means it's built from many layers of lava, ash, and volcanic debris that have accumulated over time. It had erupted before, in 1979 to 1980, and again in 2007. There's also a suspected minor eruption in 1991, but it was never confirmed. Until the events of the 1970s, Ontake was considered completely quiet, with no recorded eruptions at all. After 1980, the volcano was placed under constant monitoring. The Japanese Meteorological Agency keeps watch over it. Seismometers, instruments that detect underground tremors, and other equipment were installed around the mountain to track ground changes and volcanic gases. All of this is meant to help determine whether magma is moving beneath the volcano and whether there are hints of an approaching eruption. And indeed, in early September, before the disaster, a slight increase in seismic activity was recorded. But predicting that an explosion of this kind would happen was impossible. Why? Because forecasting volcanic eruptions is one of the most difficult challenges in modern science. When magma rises inside a volcano, it can produce noticeable signals like tremors, ground deformation, and gas emissions. If you monitor these signs closely, you can assume the volcano may be getting ready to erupt. But the problem is that these same signs can appear even when no eruption is coming. To understand how a specific volcano behaves, you need data from its past, and Ontake has almost none. Scientific archives contain only 2 confirmed eruptions, and before 1979, no one was monitoring this volcano at all. So scientists simply didn't have the long-term records they needed to learn from. On top of that, experts believe Ontake produced a special type of eruption, one that gives almost no traditional warning signs. In photos and videos taken by hikers on Ontake, you can clearly see that the ash cloud was mostly white. That's a sign that the eruption was driven almost entirely by steam. Familiar pattern, right? The ash and gas flows that came down from the summit were, as far as we can tell, relatively low temperature and not very dense. This also indicates that magma never reached the surface and didn't play a major role in the process. So what happened? Most likely, water seeped deep into the volcano and came into contact with hot rocks. It overheated rapidly, turned into steam, and expanded violently. In other words, the magma stayed inside, which is why there were no classic warning signals at all. Phreatic eruptions happen suddenly at a random moment. One minute, people are calmly walking along the trail, taking photos, enjoying the scenery. In the very next moment, everything around them erupts into chaos. So if eruptions like the one on Ontake can't be predicted in advance, is it even safe to let tourists onto volcanoes? Ontake isn't just a mountain, it's a pilgrimage site and one of the most popular destinations for hiking and mountaineering. And it's far from the only case like that. People travel to Kilauea in Hawaii to watch lava up close, climb the volcanoes of the Cascade Range in the US, and ski on Ruapehu in New Zealand. And in all of these places, sudden steam explosions are theoretically possible. What can you say? There's something undeniably magnetic about volcanoes. The raw power of nature, the dramatic landscapes. No wonder people want to be there. But volcanoes always come with a risk. And anyone who goes up there understands it's not an amusement park. The good news is that disasters like the Ontake eruption are extremely rare, so blaming people for wanting to see a volcano up close or criticizing authorities for keeping routes open wouldn't be fair. But experts agree on one thing: with the knowledge we have today, predicting or preventing this specific kind of eruption was virtually impossible. You owe me a like. See you later.